Hi class, this is lesson 7-7, solve right triangles, and this is our final lesson for chapter 7. It says right here at the top, to solve a right triangle means to find the measures of all its sides and angles. So this is a skill we'll use here in GLB, and you'll also use it next year in Algebra 2A. So you can solve a right triangle if you know either of the following, either two side lengths, or one side length and the measure of one acute angle. So if you know one of those two things, you can figure out all of the other angles and sides. So what we're going to introduce you to in this lesson is also called inverse trigonometric ratios. So we have inverse tangent, inverse sine, inverse cosine. And what these do is they all undo sine, cosine, and tangent. So if we're trying to find the tangent of an angle here, and we know we've got a number on this side, we're going to use what we call inverse tangent to find our angle. So in other words, we use the inverse functions and we write them inverse sine with a little -1, inverse cosine with a little -1, and then inverse tangent. We use those to find missing angles. If you look back at all the problems that we did to use sine, cosine, and tangent, we knew what the angle measure was. Now we're going to use these to find our angle measures. So let's use the inverse tangent function first. Okay, it says use the inverse tangent to find an angle measure. My example, use a calculator to approximate the measure of angle A to the nearest tenth of a degree. So here's a key thing. We're using a calculator to approximate the measure of angle A. That's our key piece right here. So this is the angle I want to find, and I'm going to put the little symbol theta here to represent that that's my angle. And I'm going to label my sides according to that being my angle. So the 20 is my adjacent side. The 16 is my opposite side. And then my hypotenuse is over here, and I don't know my hypotenuse. So if I want to find my angle, I need to figure out what uses adjacent and opposite. So in order to do that, I can write out the words that I've told you to remember. So, ka, toa. And if you think which of these uses adjacent and opposite, well, it's tangent right here. So the tangent function is what we're going to use. So we're going to say the tangent of our angle, so theta, equals opposite, which is 16, over adjacent, which is 20. So I'm trying to find my angle, and I just told you use inverse tangent, inverse sine, and inverse cosine to find missing angles. So I think of this as like solving an equation. If I'm trying to get my theta alone, I need to undo my tangent. So my inverse tangent is what I will use to cancel these out. And just like solving an equation, if I do inverse tangent on one side, I have to do the inverse tangent on the other side as well. So I'm going to do inverse tangent to both sides, and then I'm going to rewrite it and show you what it looks like. So those tangents cancel. I have theta, my angle, equals the inverse tangent of 16 divided by 20. And if you look at your calculator, there's a button, it's usually your tangent button, right above it, it says inverse tangent, or tangent with a little -1. So if you hit that button and then do 16 divided by 20, it will give you the value rounded to the nearest tenth of 38.7, and that's in degrees because we're finding our angle measure. Look at the next problem. It says use a calculator to approximate the measure of angle C. So now we're looking for angle C. So on my picture up here in green, here's angle C, so that's my angle I'm looking for. That's my unknown, my theta. I'm going to label my sides according to angle C now. So now 16 is my adjacent side, And 20 isn't my adjacent anymore. 20 is my opposite side. But my hypotenuse still stays the same. Your hypotenuse is always across from the right angle. So if I want to find angle C, that's my angle I'm looking for, you're going to say what uses adjacent, because I know my adjacent, and opposite, because I know my opposite. I don't know my hypotenuse, so I'm not using it. And again, tangent uses opposite and adjacent. So we can say the tangent of our angle, we don't know what it is, so we're going to just write our variable, theta, equals opposite, which is 20, over adjacent, which is 16. And just like I did up above, to get my angle alone, I'm going to use the inverse tangent. Because that'll cancel those two out. And if I do the inverse tangent on the left, I have to do the inverse tangent on the right. So now, I moved my tangent to the other side and used inverse tangent. So I have my angle equals the inverse tangent of 20 over 16. And if you put it in your calculator just like that, inverse tangent of 20 over 16, you'll find if you round it to the nearest tenth, you get 51.3, and we're finding an angle measure, so that's in degrees. These next problems here, let angle A and angle B be acute angles in two right triangles. Use a calculator to approximate the measure of angle B and of angle A and angle B to the nearest tenth of a degree. So we're trying to find angle A and we're trying to find angle B. And I told you our inverse functions are what we use to find our unknown angle measures. So if I want this alone, I have to undo sine. So I have to move it to the other side. And to undo sine, I'm going to use inverse sine. So I'm going to do inverse sine over here to cancel those out. And if I do it on the left, I also have to do it on the right. So I now have my angle A equals the inverse sine of 76/100. And if you put that in your calculator and you round it, you'll find that it's approximately 49.5 when we're finding an unknown angle, so that's degrees. For this next one, I want to undo cosine, so I'm going to use the inverse cosine to cancel those out. And I'll also do the inverse cosine on the other side. So my angle B equals the inverse cosine of 17/100. And if you put that into your calculator, make sure you use the inverse sine button, you'll get that that's approximately 80.2, and that's degrees. All right, let's look at the other side here. Okay, so here's an on your own problem. It's just like the previous one we did. It says let angle D and angle E be acute angles in two right triangles. Use a calculator to approximate the measure of angle D and angle E to the nearest tenth of a degree. So again, for this problem, I want to undo sine so that I can get my angle D alone. To undo sine, I'm going to use the inverse sine. If I use the inverse sine on the left, I have to use the inverse sine on the right. So as I'll cancel, I have D equals the inverse sine of 48/100. And if you put that into your calculator, you'll find that it rounds to approximately 28 7/10 degrees. For part B, again, I want to get my angle E alone, so I'm going to use the inverse cosine on both sides. We'll make that cosine go away and leave me with just an E. So E equals the inverse cosine of 63/100. Again, I'm trying to find an angle measure. That's why I'm using the inverse cosine. If you put that in your calculator, you'll find that it's approximately 50 9/10 degrees. Okay, so here's another similar problem. It's very similar, it's slightly different. Now we're going to have a picture. It says use a calculator to find the measure of angle A to the nearest tenth of a degree. So I know my unknown is an angle. I can anticipate using an inverse function. So here's my angle A, that's my unknown. I'm going to label my sides according to it. 26 is my hypotenuse, and 16 is my opposite. And if you say what uses opposite and hypotenuse, well, that's sine. So we can say the sine of our angle A equals opposite, which is 14, over hypotenuse, which is 26. Now to solve this, I want to get my angle A alone, so I'm going to use the inverse sign to cancel those out. And if I use the inverse sign on the left, I have to use the inverse sign on the right. So I have A equals the inverse sign of 14 over 26. If you put that in your calculator just like that, the inverse sign of 14 over 26, you'll find that it's about 32 6/10 degrees. Okay, we've got it on your own here. It says use your calculator to find the measure of angle A to the nearest degree. So let's again mark up our picture a little bit. Angle A is right here. Let's label the sides that we have. Right next to angle A, this is my adjacent, and that's 10. And my hypotenuse here is 16. I don't know my opposite, so I'm not going to use it. And if you ask what uses adjacent and hypotenuse, well, that's cosine. So we can say the cosine of our angle A equals adjacent over hypotenuse. If I want to get my angle A alone, I've got to undo cosine. So I'm going to use the inverse cosine on both sides. So my cosine and inverse cosine on the left cancel. I have A equals the inverse cosine of 10 over 16. And if you put that into your calculator, you'll find that it's approximately 51.3, and again we're finding a missing angle, so that's degrees. So our last three problems is where we get to really the big idea of this lesson, and it's solving right triangles. And so this is finding all of our missing side lengths and all our missing angles. So if I look here, checking out my angles first, I know two of them. So the three angles always must add up to 180 degrees, so I can easily find angle P. So for angle P, it's going to be 180 degrees minus the 90-degree angle that I have, minus the 45-degree angle that I have. That would leave me with 45 degrees. So there's my first thing that I need to know, angle P. Now, I also need to know on my triangle, I'm going to mark up my triangle here. I've got my angle, that's 45 degrees, that's my theta. My hypotenuse here is 12. I need to know my adjacent side, and I need to find my opposite side as well. So let's start with our opposite side. So I found my P there. Now let's find our opposite side. So looking at my picture, I need to find my opposite. I know my hypotenuse. So say what uses opposite and hypotenuse? Well, that's sine. So we're going to say the sine of 45 equals opposite over hypotenuse. So the sine 45 degrees equals opposite, which we don't know, so I'm just going to keep it OPP for opposite, over hypotenuse, which is 12. I can change this to a fraction, and then use proportions here. 1 times the opposite side is just the opposite side, equals, and then cross multiply. I have 12 times the sine of 45 degrees. So my opposite side equals 12 times the sine of 45, and if you put that in your calculator, you'll find that it's about 8.5. So there's my opposite side. Now, let's find our adjacent side. So to find our adjacent side, look here, I need to know adjacent. I know my hypotenuse and my angle. What uses adjacent and hypotenuse? Well, that's cosine. So we're going to say the cosine of our angle, which is 45 degrees, equals adjacent over my hypotenuse, which is 12. And once again, I'm going to make my left side a fraction and cross multiply. 1 times the adjacent side just leaves me with the adjacent side. I don't know what that is. 12 times the cosine of 45 degrees is what I'm having on the right side. So if you put 12 times the cosine of 45 degrees into your calculator, you'll find that your adjacent is about equal to 8.5. So that's how I find all my missing sides and all my missing angles. Here's another one where we're looking for some missing pieces here. I know one of the sides and an angle. So if I know two of my angles, I can easily find my third angle. So let's start by finding angle V again. So to find angle V, do 180 degrees minus the 50 degrees that I have minus the 90-degree angle that I have. And that will leave me with a 40-degree angle. So my angle V is 40 degrees. Okay. Now let's label our triangle according to that angle. Here's my 50-degree angle. And right next to it is my adjacent side. Across from my right angle is my hypotenuse. So those are the two things that I need to find. I need to find my adjacent side, and I need to find my hypotenuse. And then I know my opposite. So we're going to kind of like pretend, kind of like cover up one at a time. So if I cover up my hypotenuse, I have adjacent and opposite. And you can ask, what uses adjacent and opposite? Well, that's tangent. So we would say our tangent of 50 degrees, because that's what I labeled my triangle according to the 50-degree angle. Tangent equals opposite, which is 21, over adjacent, which I don't know, so I'll keep it adjacent. If I change this to a fraction, I have 1 times 21 equals my adjacent times the tangent of 50 degrees. If I'm looking for my adjacent side, I need to move that tangent of 50 to the other side. So I'll divide both sides by the tangent of 50. So these cancel out. I'm left with my adjacent equals 21 divided by the tangent of 50. And if you put that into your calculator, you'll find that your adjacent side is about equal to 21 divided by the tangent of 50 is about 17.6. So there's my adjacent side. Let's now find our hypotenuse. So our hypotenuse is right here. We're going to pretend we don't know adjacent. We're going to look opposite, because I know my opposite, and hypotenuse. Well, sine uses opposite and hypotenuse, so I'm going to write a trig problem using the sine function. So we'd say the sine of my angle, which is 50 degrees, equals, it's so opposite over hypotenuse. So I can make my left side a fraction and cross multiply. 1 times 21 would give me 21. Then I have my hypotenuse times the sine of 50 degrees on the right. I want to get hypotenuse alone, so I'm going to divide both sides by the sine of 50 degrees. That cancels the sine of 50 out of the right side. So my hypotenuse equals 21 divided by the sine of 50, and if you put that into your calculator, you'll find that it's about 27.4. Okay, we've got one last example problem, and if you look, this one is actually a little bit different than the last two problems. The last two we were given one angle and then one side. This one we're given two side lengths. So to find a third side length, we got to look way back to 7.1 and use the Pythagorean theorem. So I'm going to find my hypotenuse first using the Pythagorean theorem. So I can say my leg squared plus my other leg squared equals my hypotenuse squared. If I simplify the left side, I get 1,156 equals your hypotenuse squared. Take the square root of both sides, and you'll find that your hypotenuse equals exactly 34. So there's my hypotenuse. So I can put my 34 on here. Okay. Now we need to find angle T, and we need to find angle A. So looking at angle T, I'm going to just sketch a little picture here. If this is my angle T, then this 16 is my adjacent, and the 30 is my opposite. So what uses opposite and adjacent? Well, that's tangent. So I can write the problem, the tangent of my angle T, so I'll just write T for tangent of T, is opposite, which is 30, over adjacent, which is 16. Now to get my angle T alone, I'm going to use the inverse tangent. So I'll do that to both sides. So my angle T equals the inverse tangent of 30 divided by 16. And the bottom of my iPad, I'm having a hard time writing that. So 30 divided by 16. If you put that into your calculator, you'll find that it's about 61.9 degrees. Now to find angle A, we could set up another problem, or we could look at the fact that we now know two angles. Since I know two angles, I can easily find the third by subtracting from 180. So I can say 180 minus the angle I just found, 61.9 degrees, minus my 90-degree angle. So that'll leave me angle A equals, or it's about equal to, because I did some rounding, 28.1, and that's degrees because it's an angle that I was looking for. All right, this is the end of lesson 7.7. Make sure if you have any questions, you ask me about them, and have a great night.